This is, I'm happy to say, a very quick video on using trig identities in order to know the value of the trig function of an angle and find, say other values, or remaining values, or just desirable other trig function values of that angle. Okay, so what we're going to do is this: we're going to use identities along with only one trig function of an angle theta in order to find the remaining 6 trig functions, possibly. I'll tell you what, in this example, what we're going to do is this. We're going to say, let's let theta be an angle. And in this instance, I say not an acute angle. I'm actually going to tell you that it lies in quadrant 2. But I'll give you the value of sine. I'll tell you that the sine of this angle comes out to be a positive 1/3. What I want us to go do is find the values of cosine and tangent. And I want to use trig identities to do this. Okay, so first things first, let's go ahead and acknowledge a few things that we could draw a picture of this situation. As a matter of fact, that's what I always want to encourage you to do. If the sine of an angle theta is equal to 1/3, recall that the sine value given a point on the terminal side would be some y value over r. Okay, and the idea here is this: we know that this angle theta, it terminates in the second quadrant. So maybe our angle looks like this right here. So we'd say, okay, so here's our theta, and we know that the sine of this angle comes out to be 1/3, all right? What we want to go do is find the cosine and the tangent of this angle, and as a matter of fact, since I've already been told the sine value here, technically, in terms of the 3 values that it is that we're always considering here, x, y, and r, which ones are we already familiar with? And the thing here is this: we already know that the r value is 3, and we've been told that the y value is 1. The only one that we haven't been able to find yet is this x value down here. And so we can use Pythagoras to actually go find this. Okay. Before we do that, what I want to do is I want to kind of encourage you to deviate from the picture for just a minute and say, well, what if I didn't draw a picture? How could I go do this? And that's the whole point of this video. Do I have to draw a picture to do this? And as a matter of fact, the answer to that question is no. Since the sine of this angle is 1/3 and I want to go find the cosine of this angle and I want to go find the tangent of this angle, we're already familiar with a few basic identities like, hey, the tangent of an angle is equal to the sine of my angle over the cosine of my angle. And I also know this: given the value of, say, either sine or cosine, we could use our Pythagorean identity that says that the sine squared of an angle plus the cosine squared of an angle, this has to come out to equal 1. And so this is going to be the first identity we actually use up here that says if I know the value of sine, we can actually go substitute it in up here into this identity and find the value of cosine. And once we know the value of cosine, which, by the way, I'll just go ahead and stash it right here. Once we know sine and cosine, we can go solve for tangent. And then we'll go back and talk about why this is reasonable on our picture and why basically you should always draw a picture. But essentially, here's what we have. We say, well, if the sine of theta is equal to 1/3 in value, then we say that the sine squared plus the cosine squared of this angle is equal to 1, where we know that this value here, we're going to go ahead and substitute in for sine, is 1/3. So now squaring my third, we get a 9th. So a 9th plus our cosine squared of this angle is equal to 1. If we were to subtract a 9th from both sides here, we get 1 whole minus a 9th. It's going to leave us with 8/9, but I will, for the sake of, I don't think that all audience members here follow as quickly as I work, but we'd say we have to find a common denominator here. And so in this instance, we'd say, okay, so 9/9 minus 1/9, we get 8/9. This is what I love about using the Pythagorean identities, is that there's always a whole involved. So finding common denominators is pretty easy. So we get the cosine squared of theta is equal to 8/9. What we want is actually the square root of this. We want the cosine of theta. So we get the cosine of theta would be this. We get the square root of 8 over the square root of 9, which, as a matter of fact, we get this. We get plus or minus, and this is so important, on top the square root of 8. Recall the square root of 8. It's the same thing as the square root of 2 times 4. So this is 2 times the square root of 2, and we extract the square root of 4 here. We know that. And then we say in the basement here, we know the square root of 9 to be 3. So congratulations, we just found the value of cosine. The point of this video is this: we say, well, which sign should we affix to this here? Should it be a positive or a negative? And recall that in the second quadrant, all students take calculus. In the second quadrant, the only thing that's positive is the value of sine. So in this case, we would say that the value of cosine has to be equal to negative 2 square root of 2 over 3. Okay, so now that we have the value of cosine, we say negative 2 root 2 over 3. We have the value of sine to begin with. I'm going to stack this on top of it. We say 1 over 3. What we want to go do is find the tangent now. And again, using identities, we would say that it'd be the sine value over the cosine value, which in this case, our sine value is 1/3. Our cosine value is negative 2 root 2 over 3. And when we're dealing with fractions, recall that we need to multiply by the reciprocal when you divide. So we're going to be multiplying by 3 over negative 2 root 2, which in this case are 3's share a common factor, which is that self. You know, we get 1 over 1, 1 and 1. So we get 1 over, and in this case we say over negative 2 root 2, which in this case we need to rationalize. We get 1 over negative 2 root 2. If we were to take this times root 2 over 2, this actually simplifies out to be root 2 on top over a negative. This would be a negative 2 times that. Now root 2 times 2, root 2, that's a 2. So we get negative 2 times 2. In other words, we get the tangent value of this angle to come out to be this. We get negative root 2 over 2 times 2, which is 4. Okay, so we get this right here. Now, going back to the picture, not having used identities, could we have done this not having used identities? And I want you to notice that the first thing we're going to do is actually we're going to use Pythagoras to go find this right here. So when you say, when I use this identity up here, it's a pain in my rear, what you're really doing is doing what you would be doing over here with the picture, except for most people don't draw the picture. Now, if you're a person that draws the picture, hey, congratulations, good for you, because what we know is this. We would know that 1 squared plus x squared would be equal to this 3 squared right here. And again, you know, we'd say this is 1 plus x squared equals 9. In this case, we get x squared equals 8 when you subtract your 1 over. And so this is very much true. When you take the square root of this, you get plus or minus the square root of 8, which is plus or minus 2 root 2, which, looking at this picture now, knowing that we're in the second quadrant, you have to be able to deduce that your x value had better be negative. So we get this, we get negative 2 root 2. And again, if somebody had asked me to go find now, say, the cosine and the tangent of this, we say cosine, tangent. We know that the definition of cosine is x over r, which in this case, we were able to determine that our x value is negative 2 root 2 over our r value, which is 3, which is the same thing we were able to determine before, this negative 2 root 2 over 3. So, you know, choice between draw a picture and not draw a picture. Get in the habit of start drawing your picture when somebody gives you information like this. And then the tangent value, which would be our y value over our x value. Again, our y value here I can see is a 1, and our x value is a negative 2 root 2. And again, you know, if you were to rationalize this here, root 2, you know, we would find this out here. We would get this. We would get negative root 2 over negative 2 times root 2 is 2. So we get this is a negative 2 times a positive 2, which is a negative 4. Okay. Let's see here. Let's see. We get a positive root 2 on top. Sorry. Positive root 2 on top. And then we say over negative 4. Yes, yes, yes. Okay. So, and this was the same value that we were able to determine over here. Cheers.